Now this video is going to be quite a big video. It's got a lot of information in it, and at various points you might need to go back and have a look at things that haven't quite made sense. Whether or not you'll be able to take everything in one go, I'm not sure. It might be that when you go through the exercise you need to refer back to things that we've been speaking about, and of course I'll be available to help as and when required. Now, trigonometry. The whole point of trigonometry is it works with right angled triangles to start with. Actually later on again we go into non-right angled triangles, but to begin with we're talking about right angled triangles. Now the difference between trigonometry and Pythagoras' theorem is fairly easy. Trigonometry involves angles, and I've just drawn a little symbol here which is called theta. Okay, it's a Greek letter, and we use it to denote an angle in mathematics. Okay, so where I've got this angle in here, I'm saying that that angle is theta. Now, we also already know that this side in the triangle, the one that's opposite the right angle, is the hypotenuse. Okay, in fact I'm just going to write it as H. Okay, that's H, and H is the hypotenuse. There we go. Okay, the hypotenuse. Now, in Pythagoras' theorem, we don't worry about the other two sides. We just say they're the shorter sides. In trigonometry, we need to be able to name them. It's quite important that we know which sides we need to use and when. So, this side over here, I've labelled as O, and this side here, I'm going to label as A. This side is O because it's opposite the angle that we're working with. Okay, so O is the opposite side. Opposite. Okay, and let's just make that a bit smaller. That's opposite the angle that we're working with, as the hypotenuse is always opposite the right angle. The side A is called the adjacent side. Adjacent. Okay, it's the adjacent. It means it's touching the angle that we're working with, along with the hypotenuse, of course. So the angle we're dealing with, firstly, one side will always be the hypotenuse, the other side will be made up by the adjacent side. And the side that isn't touching the angle in any way, the one that's over the other side, is the opposite side. Now, that's really critical because trigonometry is all about the relationship between different sides of the triangle, and they depend upon the angle that you're working with. So before we go any further, I'm just going to now rub out these two and this angle, and we're going to move and suggest, well, what happens to the sides if that is the angle that I'm working with, the angle in the top corner of the triangle? Well, the hypotenuse stays the same, that's why I didn't rub it out. What does change is the opposite and the adjacent, because the adjacent is the side that's touching the angle, so that's now here, but the opposite side is the one over here from the angle, so that's moved. So the adjacent and the opposite sides have now switched over. What I'm going to do is I'm just going to pause this now, and what I suggest you do is you just make sure you're clear in your head about everything we've just spoken about. Okay? Right, moving back on. What I have now is I've just changed to a same right angled triangle. I've made it a bit bigger, and I've got here a protractor and a ruler. And the first thing I'm going to do is I'm just going to prove to you that what we have is a 30-degree angle in our right angled triangle. And you can see that the line for the hypotenuse is going off at 30 degrees. Okay, and actually that means we also know what the angle is at the top of the triangle, but we may talk about that a bit later. Let's just have a look. So we can see that this angle up here is 60 degrees. Yeah, but we would expect that because obviously in a right angled triangle we have a 90, well, all the angles will add up to 180, and the two shorter sides must add up to 90, as we have a 90-degree angle in there. Now, what I'm now going to do is I'm going to measure some of the different lengths that we have. First of all, I'm going to measure the full, the main length, which is 15 centimetres. Okay, The full hypotenuse is 15 centimetres for the big triangle. And then I'm going to rotate my ruler. I'm going to measure the bottom, which is of course the adjacent side. And the adjacent side is 13 centimetres if I'm not being particularly accurate. But we'll put that as 13. And finally, we'll just work out what the height is. And we'll have a look at that. So the height is 7.3 centimetres. I'm going to put down 7.3 centimetres. Now move my ruler aside because I will need it in a little while, but for now we're done with it. Now, what I'm now going to talk to you about is this idea of what actually sine, cos and tan are. Sine, cos, tan. Well, first of all, in a right angled triangle, the angle will denote, if you know the angle and one of the sides, you can find the other side, or either of the other sides. Or if you have two of the sides in a right angled triangle, you can work out the angle that must be in the triangle. Okay, that sounds quite difficult to understand, but let's have a look. First of all, sine. Sine is the ratio between the opposite and the hypotenuse. Okay, we'll talk more about that in a second, but if I just get a red pen, here's my angle. Sine, we just said, is the opposite and the hypotenuse. Okay, so that's what I mean by that. The 13 down here for the adjacent is not required. That is not involved if we're using sine. We'll talk again about all of that shortly, but for now I'm just going to continue by talking about what cos is. Well, cos is adjacent and hypotenuse. I haven't really given myself enough room here, so I'm going to move some of this down. Cos is adjacent divided by hypotenuse. And finally, tan, well, we've got opposite and hypotenuse, adjacent and hypotenuse. Tan is opposite over adjacent. Okay? Right. Now, what I'm going to do is we're going to, again, give ourselves a bit more room. What have we got here? Well, we've got sine and we've got a 30-degree angle. Okay, so this is for sine, we've got a 30-degree angle, and we can see that sine is opposite divided by the hypotenuse. The opposite is 7.3 and the hypotenuse is 15. So let's have a look and see what happens if we do that. We get 7.3 divided by 15, and that gives us a value of 7.3 divided by 15 is 0.486 recurring. So the 6 goes on forever. Okay, so that's from our diagram, sine 30. Now let's have a look at what cos will give us if we do exactly the same thing. I need a little bit more room. We'll move the tan over, and actually we need to also get rid of our circles, so we need a rubber. Get rid of that. This time we're still working with the angle, but this time it is adjacent and hypotenuse. And adjacent and hypotenuse would mean that for cos 30 equals 13 over 15. Which is, let's work that out, 13 divided by 15, 0.86 recurring, 0.86 recurring. And finally this tan, which is opposite over adjacent, so tan, let's just make sure again, it's no longer that one, it is opposite, it is that one, opposite and adjacent. It's the hypotenuse we don't need anymore. So the opposite and the adjacent, which is tan 30, is opposite 7.3 divided by 13. Let's have a look at what we get for that. That is 0.5614. Okay, so we've just got these sort of three random values, you might think. What is important here is the fact that we are saying for a 30-degree angle in a right angle triangle, if we do the opposite side divided by the adjacent side, it is 0.5614. That's what the word tan means. It means we're doing the opposite side divided by the adjacent side. For the cos, we got 0.86 recurring. That was when we did the opposite the adjacent over the hypotenuse. And for sine, it was opposite over hypotenuse, and we got 0.486. Now I'm going to take those three sections and just pop them over here, and we'll revisit them in a moment. Okay, let's just take that. Oh, we didn't want to spin it. We want to move it. There's the cos, and finally the tan. Let's go down a bit further, extend. And we'll put that here. Now what I'm going to do is, firstly I'm going to remove the big red line. I won't draw them this time, you'll have to try and keep track of what's going on. What we're going to do is we're going to bring our ruler back in, and instead of working with the big triangle, we're going to use this smaller triangle, so where we have the line going through the middle. And to indicate that, let's actually go over that in red. Oh, that's not red. That's red. So I'm talking about this triangle here. So what has changed? Well, firstly, what hasn't changed is the angle. The angle is still 30 degrees. We're still working with the 30-degree angle. But what would have changed is all the side lengths of the triangle. So let's just rotate and measure the different sides of our new red triangle. So firstly, this base, this adjacent side, looks to me like it's 8.1. Let's go back to back for that. So we've got 8.1 centimetres now for our short side. The hypotenuse we can measure. Rotate. That looks to be 9.4 centimetres, I reckon. And finally, we will do the opposite side. So it doesn't matter which order I do these in. Let's have a look. That to me looks like it's approximately, I'm going to go 4.5 centimetres. Okay. Oh, so we have, let's just have a tidy up. Get rid of that. And that. Because we're not using that height anymore. So, I don't know why I have a square there. But I'm also done with my ruler, so I might as well delete that and get rid of that. So, we now have all sorts going on here, and I'm not really sure why. Let's try, I'm thinking that's better. So, we're now using our red triangle. We're going to do exactly the same thing. Okay, it's still a right angle triangle, so we're okay. This time I'll do it in red. So sine of 30 in our smaller triangle, again it's opposite divided by hypotenuse, so that's 4.5 divided by the hypotenuse, which is 9.4, and we'll work that out. 4.5 divided by 9.4, and that is 0.48. 2 decimal places, that will be fine. Cos of 30 is the adjacent, which is 8.1, over the hypotenuse, which is 9.4. And that is 0.8617, ... Leave that. And finally tan of 30 is the opposite divided by the adjacent. So that's 4.5 divided by 8.1. And that is 0.5 recurring. So there we have 3 new values. Right, what I'm going to do is I'm going to move them alongside the ones we did earlier, but I'm going to start by moving the tan 30, because otherwise we're going to end up with things getting in each other's way. So there's the tan 30. Here's the cos 30. And there's the sine 30. We can move all of that out of the way. We don't need that quite so much. Let's have a look here. So we had from our bigger triangle that sine of 30 was 0.486, and in our smaller triangle it turned into being 0.48. That's interesting. Let's do that in green. 0.486 and then 0.48. So although we kept the angle the same, we changed ultimately the size of our triangle. Yet that when we do the opposite divided by the hypotenuse, we got 0.48 or thereabouts for both answers. Then when we did cos, that was the adjacent over the hypotenuse. For the first we got 0.8666666, so on and so on. For the second one we got 0.8617. So both 0.86 or very close. And finally when we did the opposite over the adjacent, we got 0.56 and then we got 0.555. Again, very close to each other. That's because for a right angled triangle, if you keep the angle, or for 2 right angled triangles, 2 different sized right angled triangles, if you keep the angle the same and you do the opposite divided by the hypotenuse, they should give you the same value. And it just so happens that if we have that value is 30, where the angle is 30, when you do the opposite side divided by the hypotenuse, it should be 0.5. Or another way to think of that is the opposite side of a right angled triangle should be half the length of the hypotenuse if the angle is 30 degrees. Okay? Same will apply for cos of 30. The adjacent over the hypotenuse will be the same regardless of the size, as long as the angle is the same, and the same for tan, which is the opposite over the adjacent. Now there's lots in this video, but I'm going to finish it off just by coming up with or giving you a way to remember the different sides of a triangle. No, that's a lie. I'm going to give you a different way to remember sine, cos and tan. So firstly, sine, cos, tan. And what we're going to do is we're going to say that sine is the opposite over the hypotenuse, and we're going to write that in order so that the one on the top is the opposite and the second one is the one on the bottom, which in this case is the hypotenuse. For cos, it is adjacent over the hypotenuse, and for tangent it is opposite over adjacent. Okay, so sine, cos, tan, and we have opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, now really what you need to remember is this bit at the top. SOHCAHTOA. SOHCAHTOA. And there's lots of different ways to remember that. Silly old Hitler couldn't advance his troops over Africa. That's quite a famous one. Should old Henry catch a herring trawling off America? That's another one. There are others that maybe I will not record here and now. You could come up with your own. But you need to find some way of remembering SOHCAHTOA. SOHCAHTOA. Because that will allow you to remember which of sine, cos and tan, which side goes with which. Now I'm going to stop this video here, but actually I haven't really spoken about how to solve problems using trigonometry. This is just a sort of a general overview of it, something that you might revisit at at a later stage as well, when you're trying to think to yourself, what on earth does all this mean? Well, this is where it comes from. Sine, cos and tan are ways of showing that the opposite and the hypotenuse are in a ratio to each other. We use all of this to solve problems, but anyway, I hope this video has given you some idea of what sine, cos and tan are. They are literally just telling an onlooker that when you write the word sine, you are comparing the opposite and the hypotenuse. When it's cosine, it's adjacent and hypotenuse, and for tan, it's the opposite and adjacent. Stop the video, have a little breather. Anything you're not too sure about, you can ask, but when you're ready, move on to the next, and you can start actually learning how we use sine, cos and tan to solve problems.